Okay, so the very first thing that we are going to discuss is medical devices, risk and benefits. Medical devices, by their very nature, are a great dichotomy. On one hand, they can offer patients with tremendous benefits to improve their lives and their health, but on the other hand, they can pose serious risk and do harm to the individuals that they aim to help. This is, of course, by their very nature, which is why we, as designers and developers or engineers, must take great care and extra precautions during design and development to do our due diligence and ensure that we make safe devices. Now, of course, when we start to do that, we start to apply the principles of risk management, and we can very quickly get caught up in a case where we're constantly looking at all the risks, all the ways our device is dangerous, but we must always weigh this up against the benefits because there's serious benefits to medical devices in how they can improve people's health. And whenever we look at risk, we must always weigh it up against the benefits and look at these two things together. So let's consider the below medical devices, both in terms of the benefits and the risks that they can pose to people. And the first one that we look at here, this is meant to be a hip implant. And on the left hand side, we'll put benefits. Okay, and on the right hand side, we'll consider just risks. So when we think of hip implants, there are, of course, some tremendous benefits that can be offered to patients. The first one is increased mobility. Which of course is something that we can take for granted when we're younger, but as we get older, and even young people can get affected by mobility. Mobility has a massive impact on your quality of life. Once people lose mobility, they stop socializing, and of course, you can spiral downhill from there. And providing people with the benefits, especially later in life, of increased mobility can have a huge impact on people's lives. So, hip implants can do tremendous benefits. Other benefits are less pain if people are suffering from hip problems causing them severe pain. On the other hand, hip implants, especially when things go wrong, can pose serious risks and do serious harms to patients. So we might consider here a hip implant poses a serious biocompatibility risk. So, and when you consider something like a hip implant, it's not the same as other mechanical devices. This is going inside the body. Once you go inside the body, everything in our body, to a large degree, has been designed largely to protect us. Our skin is a protective barrier. So too is the lining of our stomach. So too is the blood-brain barrier in your brain. When a device like a hip implant is used, it's immediately just surpassing these barriers. So your skin can no longer protect you from objects that could pose a biocompatibility risk or even a contamination risk. And so we really have to address this in the design and ensure that the hip implants are built with materials that are biocompatible and of course that they're clean and sterilized and whatnot. And let's not forget as well here that there was serious field failures in the past when companies switched to metal on metal implants. There was many cases where individuals received metal on metal hip implants and metal ions got into their blood and caused pretty horrific side effects. If you ever want to look up more on that, you can look up the documentary The Bleeding Edge, which covered many cases of people receiving hip implants and getting this metal ion poisoning, which went on to cause fairly severe harms and adverse events. So biocompatibility is one risk here. Another one that we might consider is things that you might just get from the operation. So someone's going to have to undergo an operation, so they're going to have scarring. There's going to be a risk there. So obviously some risks you can't fully mitigate, but you can try as best as you can to reduce. Our second medical device here is an AED, an automatic external defibrillator. These are the defibrillators that you see put in public places, and they're meant to be used when ordinary people basically suffer cardiac arrest and they need immediate life-saving help. As a result, a layperson can find AEDs hopefully in public spaces and use it before emergency services and personnel arrive. Now, the benefits that an AED can offer is that it is potentially will offer you life-saving treatment in emergency situations. However, on the other hand, it also poses serious risks, such as misuse. So a person could misuse the device, which could lead to cardiac arrest. And what that might be is you might have a person who doesn't actually need to be treated by a defib, but an ordinary person falsely believes they do. Like maybe you had an individual and they just fainted, and somebody runs and gets an AED, they check their pulse, they can't find it, and then they try administer electric shocks to them and put them into cardiac arrest. That's why AEDs have risk controls, such as detecting if you actually need to be treated by an AED The other one we can consider as well here is just delayed treatment. Like a person panics, it's obviously a very stressful situation that they need to be treated by an AED. Then, of course, the AED needs to be designed in such a way that an ordinary person can respond quickly in this very stressful situation and use the AED to treat the patient. And that's where you get stuff like you might be able to see there. I'll zoom in on the pads. You can see there's instructions of how to properly place the pad. It's drawn in. It's just a bit of a challenge to see. So that we can consider a risk control measure, a way of mitigating this risk of delayed treatment. And you'll also have other ones like voice prompts, etc. And information for safety, ways of instructing the operator of how to use the device correctly even in scenarios where they have never used such a device. The last one that we'll consider here is an AI algorithm that diagnoses cancer from some sort of patient images. So this one is a little bit generic as we haven't specified what type of cancer or what type of imaging, but you can consider that there could be many different applications where such a technology exists or a type of technology might exist in the future. And of course, there's tremendous benefits here because you can get earlier cancer detection before it's spread throughout the body and it's easier to treat, improved diagnostic accuracy. If the AI ever gets to a point where it has better knowledge than most clinicians, you can have improved diagnostic accuracy and, of course, increased accessibility to expertise. Okay, so when we look at it from the case of the benefits, you're like, wow, what a tremendous technology. We need to roll this out immediately. Of course, we must then always weigh this up against the risks. And the risks here are going to be stuff like false positives. An individual doesn't have cancer, but the algorithm falsely detects that they do have cancer, and then they undergo chemotherapy and they have to suffer all the awful side effects of chemotherapy. So there's some serious risks there. False negatives is also incredibly risky. If you consider a person does in fact have cancer, the algorithm looks at them and says, oh, you actually don't have cancer. That person goes on to not receive treatment for a long period of time before the symptoms get so bad they realize they have to go back and they do have cancer. So there's some serious harms associated with false negatives there. And of course, you can have things like bias in training, where the algorithm is trained on a certain data set, it performs really well on that data set, you roll it out for wider use, and it turns out its performance is not as good, both in terms of false positives and false negatives. The other thing you might focus on here is we've used the word diagnose, which kind of implies that you may have removed the doctor from the decision of diagnosing cancer. And a lot of people will instead, when they develop an AI algorithm, they'll say that the AI algorithm detects a probability of you having a certain medical condition and it's not actually diagnosing and you're not removing the human from the loop. So that's just one to be careful of there if you are developing such a device. So I'll conclude this lecture there and I shall see you in the next.